All right, so before we go to future value of annuities, let us discuss the concept of stated and effective annual rate. So stated annual rate and effective annual rate. You may call it effective annual rate. You may also call it effective annual yield. The stated annual rate could also be called nominal rate. All right, so for the sake of our understanding, let us look at a sample investment. Let us say that there is an investment on which you can earn 10% rate of return. This is an annual rate of return, and the compounding is on a semi-annual basis. And say there are two investors. There are two investors who want to actually invest money. Say, let's suppose we have investor A and we also have investor B. So these both investors want to actually invest a certain amount of money. Both of them want to invest, this is let's say time zero. So at time zero, they want to invest $1,000. This investor as well is investing $1,000 at time zero. And because the compounding is on a semi-annual basis, that means the return would be credited every 6 months. And because it's 10%, that means 5% would be credited every 6 months. So after 6 months, let's say 6 months, the investor A earns $50 and the investor B after 6 months also earns the $50, which is 5% of $1,000. So this is the return that both of these actually earn. But the difference between investor A and B is the investor A does not withdraw anything from the account and lets the return of $50 along with the $1,000 be reinvested for the next 6-month period. So let's call the investor A reinvestor. Let's use that name. While investor B will not reinvest. So what happens by the end of 12 months? Both of these two parties, both of these two investors, A and B, would earn 5% for the remaining 6 months. But the difference would be that investor A would earn 5% on 1,050 because that was reinvested. So initially 5% was earned on 1,000. And by the end of 12 months, 5% would be earned on 1,050. The reason being is, as we said, investor A reinvests not only 1,000 but also $50 by the end of 6th month, and therefore the answer is 52.5. While this second investor, which is investor B, because investor B withdraws $50, therefore all that is left for reinvestment is only 1,000. Therefore the investor B would only earn 5%, which is just simply 5% of 1,000. And previously also it was 5% of 1,000. Now if we aggregate the return, if you notice, if you look at the aggregate return or the total return during the year, it is $102.5 on an annual basis, while here it's $100 on an annual basis. If I convert the return in terms of percentage, investor A is earning 102.5 on $1,000. If we invest that, that's 10.25%. This is for investor A, while investor B is earning $100 on an investment of 1,000, that's 10%. This 10.25 and 10%, we can call this the actual return, or we may call it the compounded return. So we can give it different names. We can call it actual return, we can call it compounded return, or more appropriately, we can call it effective annual rate of return. I hope by now it's clear that effective annual rate of return is nothing but the compounded rate of return. So the effective annual rate of return for the investor A, whereby we're assuming that investor A is reinvesting, is 10.25%, assuming that it is semi-annual compounding. So this is nothing but our EAR, effective annual rate, or EAY, which is effective annual yield. The rate of return which was being promised to the investors, which is we said was 10%, this is called your stated annual rate, or it may also be called as nominal rate. So the stated annual rate was 10%, while the effective annual rate with semi-annual compounding is 10.25%. There is a quick way to arrive at this answer. If I take you a little back to this part, remember this part? We said this gives us future value of $1 grown at R for n number of periods. So for all discrete compoundings, you will say n could be number of quarters, number of months, number of days. R could be quarterly rate, monthly rate, weekly rate, and so on. And this gives us future value of $1 grown at R continuously. So if we want to do it using the formula, here's what we would do. With semi-annual compounding, we would say 1 plus R. R is the semi-annual rate to the power of number of semi-annual periods. But because we want to find the annual rate, we would assume that the total duration of our investment is 1 year, meaning a year only, right? So the total timeline is you're investing only for a year to get your annual rate of return. So in a year, how many number of semi-annual periods will be there? Obviously 2. Now this will give us the future value of $1 investment. If you want to find the rate of return, we should take out the $1 investment, that $1 which we added, and this will give us the effective annual rate for all the discrete compoundings, meaning annual, semi-annual, quarterly, monthly, daily, weekly. For all these, we would actually find the effective annual rate in this way. So here's what we will do. We would say 1 plus, in this particular example for investor A, who is a reinvestor, we'll say 1 plus semi-annual rate. How much is the semi-annual rate? Because the annual rate is 10%, so the R should be 10 divided by 2, which is 5% per 6 months. So let's say 1 plus 0.05 to the power of number of periods. How many semi-annual periods are there in a year? Of course, 2. 1 times 2 is 2. Minus 1. The answer you should get is 10.25%. If it is quarterly, you will say 1 plus quarterly rate to the power of number of quarters, 1 plus monthly rate to the power of number of months, and so on. By now, I hope you understand the concept. And if I ask you this, what do you think? When would you have the highest effective annual rate or compounded annual rate? When it is annual compounding or when it's daily compounding? Of course, when it's daily compounding, because the return gets credited to your account every day. And then of course you reinvest that every day. And therefore the compounded return would be higher, meaning the effective annual rate would be higher. If you want to find, and sorry, before we get to that, even higher than that would be if it's continuous. So amongst the discrete compoundings, daily compounding would produce the highest result, but the highest effective annual rate would be if it's continuous compounding, which will be slightly more than the daily compounding. And how would we get for effective compounding? For continuous compounding, the effective annual rate? With the same concept, you'll say e to the power of r times n minus 1. R will be the annual rate, n will be the number of years, which will be 1 because we want to find the effective annual rate. And that would give us the answer. That's how we would actually solve for the effective annual rate for continuous compounding. Now, let me show you how you could actually use your calculator to get all this done. Instead of doing it manually, you can actually use your calculator to get this done. And here is how you would do it using calculator. So this is for continuous, and this is for discrete. All right, so using the calculator, what you can do is you can press second, followed by 2, which is icon. When you press that, you will see norm. Norm stands for nominal. Nominal, or you may also call it stated. I'll go back to our example of investor A. So the nominal in our investor A case is actually 10%, right? Stated annual rate is 10%. All we'll do is we'll press 10, followed by, make sure you press the enter button, and then you scroll down. When you scroll down once, you will find EFF, which stands for effective. We want to compute the effective, so we'll leave that, we'll go down again. And what you see next is C/Y, which is number of compoundings per year. Why per year? Because we want to find effective annual rate. So with semi-annual compounding, how many compoundings are there in a year? Of course, 2. And again, not to forget enter. If it was monthly compounding, you would put 12, weekly 52, daily 365, and so on. So we need to press 2 and then followed by enter. We'll go down twice again back to effective. When we come down to EFF, which is effective, all we would simply do is simply press compute right at the top left of the calculator. You will find that, and the answer you will get is 10.25%, which is your effective annual rate of return. So as you can see, as long as you can enter nominal and number of compoundings, we just need to change the number of compoundings to 12 and so on. For all the discrete compoundings, your calculator would actually give you the answer. If you change it to monthly, you will find the number would be higher because of quicker compounding, and daily and so on. Now the daily and continuous results, the daily effective annual rate for daily and for continuously would be very close, but slightly different. How can you get the answer for effective? Are we able to count the number of compoundings per year for effective? We know for daily it's 365, right? We said number of compoundings for, are we able to count the number of compoundings for continuous compounding? No, we can't, because the number of compoundings are infinite. However, what we can try and do is get a very close answer by using a trick in our calculator. What we can do is, you know, when they ask you to find input, we can still get the calculator to give us the answer for continuous using this trick. When they ask us to input C/Y in the calculator, when we have to input the C/Y, number of compoundings per year, let's go for an unlimited number. You can just press like 9999999, because the number of compoundings are infinite. So just press as many 9s in your calculator as possible and then press enter. And then you can just simply compute the effective. You will get almost the same answer as the continuously compounded effective annual rate of return. Another thing that I would like to add is, often in the questions, if you see the textbook questions, which you will find in my video, they do ask you to, what they could do is they could give you the nominal, and they could also give you the effective and say whether, what kind of compoundings is there, what kind of compoundings would produce the same effective that has been actually given. The problem in this case is your calculator never computes nominal rate or the C/Y, number of compoundings per year. All it only calculates for you is effective. Now the challenge is, if the calculator only calculates effective, how can I get the number of compoundings per year while they have already given me the effective in the question? So here is the trick you can use, because of course questions are multiple choice. You have the 3 options. Here's what you can do. You can input the nominal, and then if in option A, let's suppose in option A in the question, they tell you semi-annual compounding. So you put the semi-annual number, meaning you put 2, and then you try and compute the effective and see, does it give you the same answer as the one given in the question? So all we're doing is we're using trial and error to see what produces the same rate as the effective. If it doesn't, then what you do is you leave that option A out, and then you look at option B. And if option B is monthly, you put 12 and then compute effective, and then see, does it give you the same answer or not? So you repeat the same exercise until you get the right answer, and then you simply choose that particular option. That's how you can answer a question like this. All right, we are done with going back to what we have covered so far. We have discussed future value of lump sum with different series of compoundings. We have discussed the concept of stated annual rate and effective annual rate, which is effective annual rate is compounded rate of return. We'll be now talking about the second section under future value, which is future value of annuities. As you can see, Enmity in your calculator is recognized as PMT. By now you should be getting some hint. Earlier we always used to say that PMT was 0 because there was no payment in this lump sum scenario. All what we had was just a single investment or a single amount that we would actually invest. But what you observe right here is it's actually a series of payments. right? You see a series of payments, and keep in mind, these series of payments could happen on an annual basis, could happen on a semi-annual basis, could happen on a quarterly basis. It doesn't matter. You could have any kind of compounding. Whatever we learned before would actually apply here as well. But the main thing is, in this series of payments, there shouldn't be any gap. So it should not be that you are going to invest $100 in year one, then nothing in year two, and then the same amount in year three. So how can we define annuity? Well, in simple words, it's an equal amount of payment, or if you want to consider it as an investment, you could say it's an equal amount of investment that is invested each period. I'm not saying each year, I'm saying each period. So I could be investing $100 each quarter or each month or each year for a certain number of periods. That means I could invest $100 each quarter for 3 quarters. So the number of periods is not infinite, rather it's finite. You can count it. You can count the number of periods. It ends at certain point. It's not unlimited, right? So that's how we actually define annuity, and we'll now dig deeper into the annuity part. So we said it's an equal amount of payment. PMT in short stands for payment. That would happen each period. That would be either received or paid. Each period for a certain number of periods, or for certain periods, in short. All right, so in short, our calculator recognizes annuity as PMT. And this is how it would actually look at. Equal amount that happens sequentially, each one after another for a certain number of periods, is actually your annuity. And there are 2 types of annuities. Number 1, you have ordinary annuity. And you also have another type, which is annuity due. So what's the difference between the two? Ordinary annuity would look something like this. So 0, 1, 2, 3. You're investing $100, then $100, and then $100. But the investment is started by the end of the period. Or alternatively, you could say, I'm going to receive $100 after 1 year, and then after 2 years, and then after 3 years. And what you're looking to answer is, how much is this annuity worth by the end of 3rd year? How much is this annuity payment worth by the end of 3rd year? The same goes here with annuity due. Here's what you're looking to answer, and you can spot the difference now once I actually show it to you. 0, 1, 2, 3. Let's say I'm going to receive $100 starting today for a total of 3 payments. So I'm going to receive 100, and then 100, and then 100, and I want to see how much is this all worth by the end of 3rd year. I hope you can spot the difference. The annuity here starts by the end of the period, by the end of the period 1. And you have to understand one thing. All these numbers that you see in timeline are end of year 1, end of year 2, or end of quarter 1, end of quarter 2, and so on. While here the annuity starts from the beginning of 1st year or 1st period, which is time 0. All right, now how would we answer this? If I assume that the rate of return is 5%, how would we answer this? Well, if I take you back, the way we answered, we actually would grow the investment, the present value lump sum, for 5 years in this example, right? And how did we grow? We would just say PV times 1 plus R to the power of n. We are growing it. We are compounding it for this time period. In the same way, we could actually reinvest this for how many periods? How many periods is that? 1, 2. 2 periods, right? We could actually grow this for 2 periods. All right, so all we're going to say is present value is 100, into 1 plus 0.05. We'll invest the $100 for 2 years and then get the answer. The second $100 we would invest for 1 year. We'll say $100 into 1.05 to the power of 1. And the last $100 we don't even invest, so we'll just say $100, because if you do times 1.05 to the power of 0, that will just simply be $1. All right, and then simply we add this up and we should get our answer, and the answer is 315.25. so your series of $100 investments that start from the end of period 1 would, and if they are reinvested at a rate of 5%, would actually give you 315 by the end of 3rd year. If we do the same here, if you notice, the first $100 is being reinvested for 3 complete periods. So we say 100 into 1.05 to the power of 3. And then the second $100 gets reinvested for 2 periods. And then the last one gets invested only for 1 period. Automatically, you can see the future value with an annuity that starts from today then would actually be bigger. And how much would it be? It would be 331.01. All right, so what do you notice? What we notice is that if we are using the calculator and entering the PMT, we need to distinguish between ordinary annuity and annuity due. Both of these cannot be treated in the same way. They should not be giving you the same future value. So how can we use our calculator to identify or to clearly set in our calculator whether it's an ordinary annuity or annuity due? Well, firstly, here is the payment button in your calculator. I'll just go back to where I have the calculator, which I have it right here. We earlier used to keep it at 0 because we used to talk about lump sum, which was a single investment, and we would consider that as a lump sum investment today. But now we would look at payments. And when we would look at payments, you would see that we'll keep the present value often as 0, and then we'll compute the future value. But we don't only have to enter the payment, we also need to specify in the calculator whether it is ordinary annuity or annuity due. And for that purpose, here's what we will do. What we need to understand is the calculator understands, and the function of the calculator is this is considered as an ending mode. And for a simple reason, the cash flows begin from the end of the period. So it doesn't begin from the start of period 1, which is time 0. Rather, it starts from the end of period 1. End of period 1 again could be year or month or quarter and so on. While in this case, the cash flows actually begin from the start of period 1, meaning it starts from the beginning of the period 1. Therefore, this should be the beginning mode in the calculator. As long as you set your calculator to ending or beginning mode, you should be able to get the right answer by just inputting your PMT in your calculator. One more thing you can recognize, the only gap between ordinary annuity and annuity due is all this result is 1 period more than the result that you have with ordinary annuity, right? How do we know that? Look, the first number is being grown for 2, the next number is being grown for 1, the last number is not even being grown. While here it's 3, 2, 1, it's 2, 1, 0. And can I reach at this answer if I need to if I need to find annuity due using ordinary annuity? Can I do that? Yes. All I need to do is just, if I could grow this for 1 more period, all I should get is 331.01, which is what you see right there. Right? So this was just for your understanding. As such, you don't have to worry about this. But for your calculator, what you do need to worry about is you need to mention whether is it an ordinary annuity or an annuity due. And for that, what we do is in the calculator, we just simply press. If you look at your calculator and pay attention to the PMT button in the TVM row, just right above the PMT, you will find BGN, which is beginning mode. There you go. Right above PMT, you will find BGN here. There you go. So all you need to do is you will just simply press second and PMT. This should display the current mode. So to change mode, first we should display the mode. And for that, how do we display it? We press second and PMT. It should display our mode. By default, it should be ending mode. So when you will press second PMT, you will find END. Now, if you want to change it, we will press second, followed by second, and enter. And now our calculator should be set to BG, and you can just simply press the clear button. A quick way to identify and know whether your calculator is set to be in a beginning mode or ending mode is look at the top of your display screen, right side top. And if there is nothing there, if it's absolutely clear, then that means it's ending mode. But if you find a small BGN right at the top, that means your calculator is in beginning mode. So you need to pay attention to that, and you need to make sure before you do any calculation related to Enmity, you always set your calculator to a proper mode. Another thing, if we have to use, so once we change the mode, let's say if we have to get the answer for the above two annuities, for the annuity due, here's how we could actually answer this. We would say, in this case, okay, let me write that here. We would say first, let's set the calculator to ending mode. Once we set our calculator to ending mode, N is 3, we have 3 payments. An easy way to tackle annuities is to consider and interpret N as number of payments. So I often like to say that in the context of annuities, you should interpret N as number of payments, not number of periods. That makes it slightly more easier. That would make your life a bit easier. So let's say N is payments, and there are 3 payments with the ending mode. The interest rate, we are assuming it's 5%. And is there anything else that we are investing other than these 3 series of annuity payments? There is nothing else. So at time 0, we are not investing anything else. So this should be, present value should be 0. So PV 0 is actually 0. All right. And what else can we actually do? We could also, we'll put the PMT then. We need to enter the PMT. How much is the annuity payment? That's 100. And all you should do is just simply press compute future value, and you should get 315. As for the beginning mode, as for this annuity due, here's what we do. I'll just write it here. Again, the number of payments should be, let's say 3. We want to find the future value right here. So we will assume it N is 3. The interest rate is 5%. Make sure to keep your calculator in beginning mode. Are we investing other than this annuity 3 annuity payments? There is nothing else at time 0. So since there is nothing other than the annuity payment, we'll keep the present value as 0 and the annuity payment as 100. And then all you could do is you could just simply press compute and future value. That's how you would actually solve for this. Let me also show you another method of actually getting your answer. There is another trick in the calculator which would also be very handy, and I would show it to you right now. You can use that function to actually get your answer. So at times this approach is a lot more easier, and I would leave it to you to decide which approach you want to actually use, whether you want to do it this way or you want to do it using the other method I'm actually going to show to you. I repeat again, and this should be clear by now, that ending and beginning only matters when we speak of annuity. When we speak about lump sum scenario, then ending, beginning doesn't matter. Whether your calculator is in beginning mode, ending mode, it won't actually make a difference in the result. It only makes a difference if you're using TVM to get the future value or present value for annuities. But the other method which I'm about to show to you, in that method, beginning, ending, you don't have to set the calculator to beginning mode or ending mode because the adjustment would happen in the cash flow. So let's look at the second method. I'll write ordinary annuity here. And we know this starts from 0 quickly. Sorry, it starts from 100, from 1 time 1, just a correction. And then annuity due, it's right here, starts from time 0. All right, so here is what you're going to do actually. If I take you to calculator, right here, just look at what is right above the interest rate. We have a cash flow burden where we could actually input the cash flows. All right, so let's look at the cash flows and let's try and enter these cash flows. So all we would do is, as a first step, we press CF. Just a word of caution before we go ahead. For you to be able to do this calculation that I'm about to show to you, that this approach, you need to have Texas VA2 Plus Professional Calculator, not the basic version. The basic version doesn't have this functionality. This can only be done in the Pro version, so make sure you have the Pro version. It does have some extra features that the basic version actually lacks. So press CF. Once you press CF, you always need to make sure that you actually clear your cash flows. So I'm just, even though your calculator, if you have not used it before, it should be, there shouldn't be any cash flows, but get used to clearing your cash flows. So press CF and then press second and clear work. They should just simply erase your cash flows. All right, once we do that, once you have cleared cash flows, so what you see is after having pressed CF, you will find CF 0, cash flow 0. What is the cash flow 0 right here? There is no cash flow at time 0. So you'll say 0 followed by enter. And then you press down. You see cash flow 1. Right after cash flow 0, you will find in the calculator cash flow 1. How much is our cash flow 1? It's 100. We will press 100 followed by enter. So get used to pressing enter always. And then we go down. When you go down, you will find frequency of 1. What does that mean, frequency of 1? Well, that means the number of times 100 or cash flow 1 has happened one after another. Actually, this would help us save time instead of having to enter 100 in cash flow 1 and then in cash flow 2 and then in cash flow 3. And let's suppose if we had more than this, then this would take so long to enter into the calculator. As long as we have an annuity that happens one after another, and we can enter its frequency and save ourselves time. So because 100 is happening one after another for certain number of periods, for how many periods is that? That is exactly what we will enter right here. We have 3 payments of 100, one after another. And again, you press enter. That's it, we are done. We don't need to enter anything more. The calculator already knows you're going to have 100 starting from time 1 all the way until time 3. So this is your step 1. After we have done step 1, the step 2 is going to be, we'll press a button right to the right of cash flow, which is NPV. So you will just simply press NPV. PV is present value. And when you press NPV, it will ask you for interest rate. We know from the previous example, it was 5%. So we'll press 5 and enter. We go down. We don't want to find present value. We want to find future value, right? That's what the whole topic is. So you go down twice. And now you find NFV, net future value. All you do is simply press compute after you see NFV. And when you press compute, you should get 315.25. There you go. This method might sound cumbersome now, but you will notice in a lot of questions, it could actually come in handy. So it's important to know this. Okay, if it was annuity due, how would we do it? I'll just quickly show it to you. Step 1 would be, when you press cash flow, you would have to enter CF0. How much is CF0? It's 100. And then you press enter, and then you go down. When you go down, you get cash flow 1. Notice there is no frequency for 0. That's an extremely important thing you need to pay attention to. There is no frequency for time 0 cash flow. There is only frequency for cash flow 1, cash flow 2, and so on. All right, so we're not entering any frequency. The calculator doesn't even have that. We will enter cash flow 1 separately as 100 and enter and go down. Now it asks us for frequency of 1. How many times did it happen from here? It happened 2 times. Now keep in mind, where do we want to find the future value? We don't want to find the future value here. If we want to find the future value here, the last cash flow we should enter should be this one, which we have already entered. We have said that we have 100 happening 2 times. But we don't want to find the future value at time 2. We want to find the future value at time 3, right? That's what we want. So hence, the last cash flow we should enter in the calculator should be here. So our calculator would give us the net future value at a point in time where we have entered the last cash flow. So far, we have reached here in terms of cash flows. Then we enter this. And then all simply we would do is we'll go down. And what is next cash flow? After having entered all these, the next cash flow, there is no cash flow here. So we would say 0 and enter. And frequency of 2 is it only happens once. Now we pause here. The last step is extremely crucial. How does your calculator know where should it give you the NFV, net future value? In short, the answer to this is the calculator gives you the future value at a point where you have entered the last cash flow. So if you have entered the last cash flow at time 2, it will give you the NFV or the future value at time 2. If you have entered the cash flow until time 3, it will give you until time 3. So that's how it actually goes. And then you will do the step 2, you press NPV, you enter interest rate as 5%, and then you go down twice after pressing enter. When you compute, you should get 331.01. Notice, we don't have to care about changing the mode from beginning to ending because we're already making the adjustment in terms of cash flows. All right, so we'll now take a look at an example on this topic. It says, suppose your company's defined contribution retirement plan allows you to invest up to $20,000 per year. So from this, it should be clear, you're investing each year $20,000, which means this is an annuity. This is not a lump sum. You plan to invest $20,000 per year. Again, it could be per year, per quarter, per month. As long as it's per period, it's an annuity for the next 30 years. Historically, this fund has earned 9% per year on average. Assuming that you actually earn 9% a year, how much money will you have available for retirement after making the last payment? So they want us to find the future value. Now, one thing that this example doesn't make clear is it doesn't tell us whether does the annuity begin from today or does it begin from the end of year 1. Normally, in exam questions, they will always make it very explicit. Here, since we are making a contribution, you would assume it will be by the end of the period. So the timeline would look something like this. So it's 20K, 20K. You are actually going to invest all the way until time 30, and we want to find future value right here. Again, we have 2 methods. We can use our calculator, so we can set our calculator to ending mode, which this method in this case should be straightforward. And we will say N is number of payments, which is 30. Interest rate is simply 9%. Your present value, you're not investing anything here. Present value is 0. The payment is 20,000. You could put it as negative 20,000. It's up to you because you're investing, therefore money is going out. If you don't put this as negative, your future value would be negative because always one of the 2 cash flows have to be negative. Compute future value. And the answer is it should be 2.726 million. So this is method 1. If we do method 2 using cash flows very quickly, I'll just write this down for you and then you can practice it. You can pause and practice. Step 1 would just simply be you press CF. When you press CF, you'll have CF 0 is 0. You make sure you press enter. Cash flow 1 will be 20,000. And with the frequency of 1 being 20, once you enter all this, your step 2 would just simply be you press NPV. Your I would be 9%, and you press enter. You go down twice, and when you see NFV, you press compute, and you should get your answer. Going back to our summary, we have discussed right now the two scenarios: future value of lump sum with different series of compoundings and future value of annuities with different series of compoundings. Our last section would be unequal cash flows. I would just like to make a point here. When we speak about annuities, we have only looked at an example of annual compounding. You could have an annuity with quarterly compounding or monthly compounding. For example, I'm going to invest $100 each month for the next 3 months. So what you need to be aware of is that N will be number of payments which are monthly, and your R should be monthly rate. So you will still have to adjust your R and make sure you don't forget to actually do that. So that's one point you need to actually remember. We look at a last section, which is future value of unequal cash flows, which is what you actually see here. So I look at a simple example for this, which is our last section is future value of unequal cash flows. All right, for this section, here's what we could look at. Let's say I would be investing starting from next year into an account 3 different amounts. I'll be investing $1,000 by the end of first year, $2,000 by the end of second year, and let's say $2,500 by the end of third year. And I want to find what is the future value of all these 3 investments by the end of third year. And assuming that the return that I would earn on this account would be 5%. So there are 2 ways. Either you do it manually, considering each as a lump sum and growing each. So you would say 1,000 into 1.05 to the power of 2. And then this one you would grow as 1,000 to the power of 1.05 times 1.05 to the power of 1. And then the last one would just simply be 2,500. And then you add these 3 up as we did before. But this could be very cumbersome and very lengthy procedure. So to cut it short, you could actually use your cash flow function. If you thought of it, that's great. You could just simply use cash flow function. And how do you use your cash flow function? Just press CF. And when you press CF, you will enter cash flow 0. There is no cash flow, it's 0. Make sure you press enter. You go down. Cash flow 1 is 1,000. You press enter. When you go down, it will ask you for frequency. Make sure it's 1 because it only happens once. And then you go down and you see cash flow 2, which will be 2,000. You press enter, you go down, you find frequency of 2. How many times this 2 happens? 1 time only. And then you go down to cash flow 3, which would be 2,500. You press enter, you go down. Again, that's 1. And once you have entered all this cash flow, this was our step 1. Our step 2 would be you press CF. And when you press, you don't press CF, you press NPV. It asks you for interest, which is 5%. Make sure to press enter. Go down twice. When you see NFV, all you do is you just simply press compute and you should get your answer. And the answer is 5,702.5. And if you add these 3 up, you should end up with the same answer, which is 5,702.5. So with this, we are done with future value of unequal cash flows, and we have finished all the 3 sections: future value of lump sum with different series of compoundings, annuities with different series of compoundings, and unequal cash flows with different series of compoundings.